Hello Year 12, welcome to week 5 review. In this week you were studying network protocols, other protocols, as well as how they fit into the network layering process. So we'll start with an overview of what actually a data packet is. This idea that you can see on screen that when a message is being sent, that the protocols, these bundles of rules, break it down into a data packet. And the rules will outline the contents of a data packet. It will have a header and it will have the payload or the actual data. And you can see that the header will be made up of different pieces of data. For example, a MAC address and an IP address of both the sender and receiver. It will include a sequence identifier so we can reassemble the packets. It will include some type of error checking method like a cyclical redundancy check. And all these rules are defined within network standards. We are also trying to look at how these fit in with the layered model and, for example, TCP/IP. If you look at the images as on screen, that you will see that at each layer, for example, the application layer, it will look after protocols like HTML, how to display a web page on screen. It will also look after protocol sets of rules like HTTP, the Hypertext Transfer Protocol, how we request a web page. Those protocols, because they're based on the first layer, or if you like, sometimes called layer 7, the application layer, they have to be able to communicate with the layer below it. For example, the TCP/IP protocol. So when data is assembled and encapsulated and passed down through the layers, each layer can communicate with the layer above it and the layer below it. And that's the concept of layering within the network protocols. So let's move on and look at our homework questions. So you had five questions, and I'm just going to highlight the key terms that marks were awarded for. So the first one is all about sending networks, this idea of packet switching networks. There was a mark for if you explain TCP/IP uses packet switching. Again, data is broken down into packets. There was a mark point for that. Messages are broken down into segments. Another mark point that they had a sequence identifier and that they could be reassembled. They're sent out individually and they could be reassembled with a sequence identifier. And again, it's this concept of network protocols that are responsible for this. If you went in and explained the contents or the anatomy of a data packet, for example, the data packet contains the actual payload and the header, and possibly give information on what's in the header. An explanation of what happens if they arrive out of sync, that the sequence identifier can be used to reassemble them. And also there was a mark point for available that they're fault tolerant because they use some type of error checking, for example the CRC, that if they arrive and one packet has been dropped, they can ask for a resend, and we said that that's fault tolerant. So there's about 7 or 8 mark points in that, and you just had to get any 5 of those to be awarded full marks. The second part of the question was, what is a protocol? And all we're really looking for is rules for network communication. Again, that came up last week. Slightly more complex, and if we go back and look at our layered model, you can see, look, what is the purpose of this here? Well, if you look at the image, that you see that HTTP is a set of rules in itself for transmitting data, for making requests to a web server. But TCP is responsible for assembling data packet, different elements of the data packet. Those two rules are very complex, but they need to interact. So if we break them down into layers, first of all it does is it makes each layer interoperable. They can work with one another, and it's very easy to break down the functionality so that certain applications and engineers can work with, say, HTTP or file transfer protocol at the application layer, and other people down at the bottom, the electronic engineers, can work at level 0 at the physical layer, looking at cables, etc. So it divides up the functionality, but it also guarantees that they're interoperable, that they will work with one another. So any of those 2 points, that if you were saying that it divides up the network functionality and also it allows for interoperability, if I can spell that, interoperability. ability. Right. Next is layers. Describe one advantage. And again, we've got interoperability as an advantage, and this idea that again that they're self-contained, that they're modular in nature. So developers can concentrate on one aspect, and again they work with each other. Final question was back to the start of the unit, and that was star networks. And again, we're looking at any four advantages of the star networks. Too many people went in and looked at, I don't know, was it the mesh topology instead of focusing on the star. But we've got, if one fails, it only affects that. Easy to find faults, easy to upgrade and add extra devices, and it's generally secure because the data is only sent to that individual device that's required. So you've got the answers. Take a chance, pause that on screen, go through, make sure you understand everything that we've covered in this unit. Make sure you've submitted your multiple choice quiz, and we will start back again after midterm with the new unit 1.6. So have a good break, and I'll chat to you on Monday after midterm.